It's a high-flying, gravity-defying freestyle skiing event making its Olympic debut in Sochi, Russia. Ski slopestyle. One of the leading contenders for the United States is 19-year-old Nick Gepper, one of the top slopestyle skiers in the world.
Puts it in first place.
Slopestyle is, to me, one of the most fun things you can do on skis, and to be able to do that at a competitive level in the Olympics and have that amount of exposure and that amount of eyes on us at once, I think is going to be a huge opportunity.
Slopestyle skiing takes place on a downhill course with a series of features such as rails and jumps that Gepper must ski, grind, and jump off to impress the judges.
You have the run mapped out in your head, and you know what moves you're going to do and what grabs you're going to get and what rails you're going to hit.
Gepper nails his tricks by relying on physical skill and the laws of physics.
When you see an athlete that's just being incredibly brave and just launching themselves out into the air with no safety net, relying on their skill to land them properly, then I think it's amazing when they do it well. This one here.
Gerton is an associate professor of physics at the University of Utah and supported by the National Science Foundation. To understand the physics of slopestyle skiing,
just act kind of natural like you're not here.
We filmed Gepper with a high-speed camera to capture his every move on the slopes. Before pushing off at the top of his run, Gepper is loaded with potential energy, or stored energy. As he skis down the course, that energy is mostly converted into kinetic energy, the energy of movement. By bending his knees as he approaches a feature, Gepper is loading himself with additional potential energy to launch into the air, what he calls popping off.
Popping off of a jump or off of a rail basically means jumping off the end of the takeoff of the rail or the jump. And that just initiates your height and your air time.
If you think of a spring and you take each end of the spring and you compress it, then you've put potential energy into the spring.
In order to perform his tricks, Gepper relies on a property in physics known as angular momentum, created when torque, a twisting force, is applied to an object, or in this case, his body. The more angular momentum he creates, the greater the potential to spin.
Your body is a key factor in how you initiate spins and keep spins solid in the air.
They're exerting torque on their skis through their boots, through their ankles, their knees, and the rest of their body. And again, that's sort of like loading up this spring, except for now the spring is a twisting spring instead of a compressing spring.
Once Gepper is airborne, he cannot change his angular momentum, but he can control his rotation speed by using his arms to increase and decrease his moment of inertia, the resistance an object has to a twisting force.
Start with your arms out. You ready?
Yep.
Gerton shows how moving one's arms closer and further away from the axis of rotation changes the moment of inertia.
So by changing how much of your mass, your arms and your legs and your skis are close to your body, close to the center of your body, or farther away, you can control how fast you spin and rotate.
This same concept is what makes Olympic aerialists and figure skaters spin effortlessly. When Gepper jumps or twists onto a rail, he relies on another physics concept to control his motion: friction, the resistance created by one surface or object moving over another.
Their skis are exerting friction on the rail and vice versa, and that helps them to control their speed while they're sliding.
Rails are probably what I think is the most fun aspect of what we do. You're sliding on metal and not snow. And it's really cool though, because you can use your edges of the skis to change your momentum.
By mastering the physics of slopestyle skiing, Gepper hopes to have all the momentum he needs to land on the podium at the 2014 Olympic Winter Games.
Puts it to it.